Hello friends, subscribe my YouTube channel Allpedia Information and press the bell icon to never miss any updates from us. In physics, power is the rate of doing work, the amount of energy transferred per unit time. Having no direction, it is a scalar quantity. In the international system of units, the unit of power is the joule per second, J, known as the watt in honor of James Watt, the 18th century developer of the steam engine condenser. Another common and traditional measure is horsepower, comparing to the power of the horse. As a physical concept, power requires both the change in the physical universe and the specified time in which the change occurs. This is distinct from the concept of work, which is only measured in terms of the net change in the state of the physical universe. The same amount of work is done when carrying the load up a flight of stairs, whether the person carrying it walks or runs. But more power is needed for running because the work is done in the shorter amount of time. The output power of an electric motor is the product of the torque that the motor generates and the angular velocity of its output shaft. The power involved in moving a vehicle is the product of the traction force of the wheels and the velocity of the vehicle. The rate at which a light bulb converts electrical energy into light and heat is measured in watt. The higher the wattage, the more power, or equivalently, the more electrical energy is used per unit time. As a simple example, burning 1 kilogram of coal releases much more energy than does detonating a kilogram of TNT. But because the TNT reaction releases energy much more quickly, it delivers far more power than the coal. Power in mechanical systems is a combination of forces and movement. In particular, power is the product of a force on an object and the object's velocity, or the product of the torque on the shaft and the shaft's angular velocity. Mechanical power is also described as the time derivative of work.